Now this is where things get exciting. This is an SBC, or single board computer. This here is a Raspberry Pi 3 Model B Plus. It's the latest model to come out. And as the name, the SBC, single board computer, as you can probably guess, this is an actual computer. This is a whole computer on a board that fits in the palm of my hand. It has 4 USB ports. It has Ethernet to connect to your local network. It has HDMI. It has camera input outputs, as well as you can use these for display ports, as well as, like I was saying with the single development boards, it has these pins which then allow me to connect my own electronics, and I can also attach things like touch screens and other displays, all sorts of things on these units. The board itself, it has a 4-core quad-piece CPU, central processing unit. So this is a genuine bona fide computer, very close to it has the same specs as you could get on a mobile phone or even a tablet. It even has a micro SD port here. Now this is what actually holds the operating system. You first flash your SD card with an operating system like Linux or Android for like a mobile phone, or even Windows. You can actually load Windows 10 onto this and have it exactly like a computer, which then means you can then plug this directly, because it's got HDMI, you can plug this directly into your TV and turn your whole TV into a computer using these USB ports to connect your keyboard and mouse to, or go wirelessly. But also the other beauty, which I haven't mentioned with these, is it also has Wi-Fi and Bluetooth. So through your programming, you can actually program a Wi-Fi network. You can Bluetooth devices directly to this. So what people use this for is a lot more fun. So like I said, with those small developer boards, and you could use both of these hand in hand. So a developer board, like I said, is basically for a small simple program where you want a repeatable task or simple user interaction with the board itself that doesn't have an overly excessive use of power or brainage, let's say. So it's doing a set of simple tasks repeatedly through to infinity, or whenever you want it to do that particular task. These SBCs, single board computers, do everything your computer does. This does everything your computer does, and because of its Ethernet and its USB ports, its memory is expandable. It's comparable to a decently fast computer. You know, you can turn these into little gaming boxes. People use them for web servers or virtual private networks. Or media servers. I've seen a lot of these. There's like, you may have heard of media boxes, where you have a box that you plug into your TV, and that stores all your recorded TV programs and your videos and your audio, and then you can have a simple user interface through your TV remote control that allows you to access all that. You can do all that with one of these as well, and because it's then networked, if you network your TVs or your computers to it, it's then accessible by every instrument on the network. There's a myriad of possibilities with these things. I bought this one specifically, and I've only just got into single board computers because I've been more down at the raw stage of developing just the single chip itself. But I've just recently got a 3D printer. And I'm going to turn one of these into it will basically monitor my 3D printer. It will send prints to my 3D printer. Basically, when you're printing with plastic, there is an odor to that. Obviously, there's hot plastic coming out. The printer itself can be very noisy as well, so I don't want that printer in the same room that I am normally working in. So instead of having to physically get up and walk to the 3D printer to make sure it's working properly and to give it its printing printing processes, etc. Because the printer itself that I've got simply takes an SD card. You just slot an SD card into it, and then normally with the printer interface you would then tell it through touching a couple of buttons to then set the print and to go off and print the project. By attaching one of these to the printer, I can automate that complete process. I can network it so that I can then access the printer from any of my networked computers, and then I can even attach, which I'm going to do is attach a small camera that will come out of this viewport here. That camera will then monitor the printer itself, because occasionally when you're printing larger 3D print jobs, something can go wrong, and instead of then having, you really should be checking your 3D printer usually every 15 minutes, at least to start off with when you're learning, to make sure the print job's working. So for that reason, if I attach a camera here on this board, I can then network that through my home network, and I can access that camera through my work computer. So I don't have to get up and walk physically to the computer to see if it's doing what it's supposed to do. I can just log straight into this networked board, either through the Ethernet or through Wi-Fi, because this takes Wi-Fi, and off we go. So this is an SBC, a single board computer, a Raspberry Pi 3. There's a couple of different companies out there, but this is the most well known and probably has the most already available programs out there and database on how to use it and what you can do with it, etc. We can then go still Raspberry Pi, but a different model version, which is the Raspberry Pi Zero W. Let me get the shade out there. So this is a much smaller board, but it still has pretty well much the same powers. It still has Wi-Fi. I'm not sure, I don't think this one has Bluetooth, but it still has Wi-Fi, so it's connected. You can wirelessly connect it through the Ethernet. It still has a video port and a HDMI port, so you can plug it directly into your TV to use that as your monitor while you're programming. You can Wi-Fi through to the Ethernet. Now a lot of people, what they'll use these for is something like a home security system. You can set these up with cameras. You just again plug a small camera into these ports here. You can have these wirelessly throughout your property, and then have them networked up through your Ethernet and through a single program, which you can then check. You can activate motion sensors, all those type of things. Again, this board still has this same, if you could see here, the holes here translate to the same thing on this board. The pins have already been soldered in. These are just without the pins already soldered in, so it makes the board nice and flat. I mean, look how thin that is. That's incredible. But again, you know, if you broke open your phone, you would see something similar on the inside, except it wouldn't have a HDMI port for sure. But it's quite amazing that something that small, you know, it fits on my finger, has a lot of processing power. Again, this takes a micro SD card, so you slot that in. It takes a Windows, Linux or Android operating system, and you know, your imagination is really the limit of what can be done with these things. So this here is $15 Australian, and it's basically got a hell of a lot of capabilities. This Raspberry Pi B Plus is $50 Australian, which is still a really good price. You're actually looking at a decent computer, and like I said, you can turn this into a tablet with touch sensitivity. You can plug it directly into your computer, into your TV, and turn your TV into a smart TV. You can have it running automated projects as well, but at a much higher, not only speed but intelligence as well. And with these, being that they have a GUI, a graphical user interface, or an operating system like Windows and Linux and Android, it makes them a lot simpler and a lot easier to use. You're still, having to write programs, etc. There is definitely more accessibility to these, particularly for beginners, and there's a huge database, not only through Wiki and through the YouTubes and Googles, but even from the Raspberry Pi website itself, and because it's open source, there's millions of contributors, and they're developing new things all the time. And the beauty too with this is, with this particular, or all of the Raspberry Pis, they're already 3D print files to print cases out, which is obviously something that I will do. The print case for, I think the print case was about half the price of what this actual board was. This board was $15, and I think the case, sorry, not the print case, the retail case, to buy a case for this to house it, I think was about $8. But I can go online, download the print files for free, and 3D print a case for it, and exactly the same here. And there's more designs out there than you can think of, so that's definitely one thing. But these great for hobbyists, and I think you're going to see a lot of these around. If you look up the Maker community, which is just MAKEI, all makers will know about these and will use them in quite a lot of their projects. And that's it for now. See ya.